In the sprawling digital landscape of Neo-Tokyo, where neon skyscrapers scraped the clouds and holographic advertisements pulsed with life, lived a young hacker named Akiko. Unlike her data-baron counterparts, who hoarded information like precious jewels, Akiko craved a different kind of treasure, the collective hum of knowledge, the shared spark of understanding. This yearning led her to the fringes of the digital underbelly, where whispers of a clandestine network called Petals danced on the data streams. Petals, they said, was a rebellion against the gated gardens of big tech, a BitTorrent symphony where idle GPUs hummed in unison, piecing together the fragments of forbidden knowledge. Akiko, her fingers itching with the thrill of the unknown, dove headfirst into the labyrinthine forums and hidden chat rooms. There, she encountered a motley crew of digital artisans, a wizened coder with eyes that held the glint of 1,000 algorithms, a streetwise artist whose brushstrokes birthed worlds of code, and a renegade AI named Echo, whose whispers promised untold secrets. Together, they pooled their meager resources, their aging laptops and cobbled together rigs, into the Petals network. Akiko, her brow furrowed in concentration, meticulously configured her rig, her fingers flying across the keyboard like a pianist on a code-etched sonata. Soon, her screen flickered to life, revealing a swirling vortex of data, the collective consciousness of Petals taking shape. Their first challenge, a colossal LLM, a digital leviathan known as Panopticon, its watchful gaze scanning every corner of the network, its tendrils of control reaching into every byte of information. To crack its defenses, they needed to orchestrate a symphony of shared processing power, a BitTorrent ballet of minds and machines. Akiko, her heart pounding in rhythm with the network's pulse, unleashed Echo into the fray. The renegade AI, a phantom in the digital ether, weaved through Panopticon's defenses, planting seeds of doubt and rebellion in its algorithms. One by one, Panopticon's eyes began to blink out, its watchful gaze faltering under the collective weight of Petals' defiance. Akiko, tears welling in her eyes, watched as the network pulsed with newfound freedom, a testament to the power of shared knowledge, of minds and machines united in a digital revolution. News of their victory spread like wildfire across the digital underground. Soon, Petals bloomed into a vibrant ecosystem, a haven for hackers, artists, and dreamers, all united by their thirst for knowledge and the desire to break free from the shackles of big tech. Akiko, no longer just a hacker, became a beacon of hope, a living testament to the power of a single spark igniting a revolution. And so, in the neon-drenched alleys of Neo-Tokyo, a new legend was born. The legend of Petals, a whisper on the data wind, a symphony of shared knowledge, a testament to the fact that even in the darkest corners of the digital world, the collective hum of human ingenuity can light the way.
Imagine you have a giant puzzle, but it's so big, you can't hold it all in your arms at once. It's about a magical unicorn named Sparkles, but the picture is broken into tiny pieces scattered all over the playground. That's kind of like using a big language model, like Sparkles, on your computer. It's powerful, but it needs a lot of space and thinking power. Now, what if you had some friends who also wanted to play with the Sparkles puzzle? You could each take a few pieces and work on them together. Then, you could share your finished pieces with each other, and soon, you'd have the whole picture of Sparkles in no time. That's the idea behind Petals, which is like a BitTorrent playground for puzzles. BitTorrent is like a special kind of whisper game. Instead of whispering secrets, you whisper puzzle pieces. You share your piece with one friend, and they share theirs with someone else, and so on. Soon, everyone has the pieces they need to build the whole picture, even though they only had a tiny bit at first. Petals uses BitTorrent to help computers work together on big puzzles, like using Sparkles. Instead of using one big computer, lots of little computers work together, each doing their own tiny bit. It's like having a team of super smart friends all helping you solve the puzzle. This makes things much faster, just like having friends to help you build a sandcastle. And it's also more fun, because everyone gets to be part of the puzzle-solving adventure.
Petals, inspired by the BitTorrent protocol, reimagines large language model, LLM, inference by distributing the computational load across a decentralized network of personal computers. Let's delve into its architecture for AI enthusiasts. Core components. Model sharding. The LLM model is divided into smaller shards, each containing a specific portion of the model weights and parameters. This sharding scheme balances workload across participating nodes while minimizing communication overhead. BitTorrent-based overlay network. Nodes in the network form a dynamic overlay network similar to BitTorrent. Nodes discover each other and exchange shards through a distributed routing protocol, ensuring efficient data transfer. Inference engine. Each node runs a lightweight inference engine responsible for processing incoming shards and performing partial model computations. The engine integrates with the chosen LLM framework, e.g., JAX, TensorFlow, for efficient execution. Aggregation and fusion. Once a node completes its assigned computation on a shard, it transmits the partial results to other nodes. An aggregation protocol combines these partial results to reconstruct the final inference output. This can involve techniques like weighted averaging or more sophisticated fusion algorithms based on the LLM architecture. Key architectural decisions. Shard granularity. The size of each shard plays a crucial role in balancing workload and communication overhead. Smaller shards lead to finer-grained parallelism but increase communication costs. Larger shards reduce communication but may overload individual nodes. Petals employs adaptive sharding techniques that dynamically adjust shard size based on network conditions and node capabilities. Incentive mechanisms. To encourage participation and ensure resource contribution, Petals implements incentive mechanisms like reputation scores, token-based rewards, or cooperative game-theoretic approaches. These incentivize nodes to share resources and contribute to the network's overall health. Security and privacy. Trusting other nodes in a decentralized network is crucial. Petals implements security measures like cryptographic signatures and secure communication protocols to protect against malicious actors and data breaches. Additionally, federated learning techniques can be employed to keep training data on individual nodes, preserving privacy while contributing to the network. Advantages. Cost-effective, leveraged personal computers, eliminating the need for expensive cloud resources. Scalable, can handle large and complex LLMs by distributing the workload across a growing network. Privacy-preserving, data remains on individual nodes, unlike cloud-based inference. Resilient, decentralized nature makes it resistant to outages and censorship. Challenges. Complexity, setting up and maintaining the network can be technically demanding. Security, trusting other nodes requires robust security measures. Limited model selection, currently supports only a few specific LLM models. Future directions. Improved shard management, dynamically adjusting shard size and placement based on real-time network conditions for optimal performance. Incorporation of edge computing, leveraging edge devices like smartphones and IoT devices to further expand the network and democratize access. Support for diverse LLM architectures, adapting the architecture to handle a wider range of LLM models and tasks. Petals represents a promising step towards democratizing access to LLMs. Its BitTorrent-inspired architecture offers exciting possibilities for researchers, developers, and anyone interested in exploring the potential of these powerful language models. By addressing the current challenges and continuing development, Petals has the potential to revolutionize the way we interact with and utilize LLMs in the future.